This video is about skill 14, which is factoring by grouping. Now, we have in a way already done factoring by grouping when we did our factoring of three-term quadratics, or the cases where we had three terms with x cubed. But now we're going to be moving to four-term expressions, and we're going to find that the grouping process is actually very similar to what we have been doing already. And for these, you don't even need to do the ACB chart factor tree because they are already written out as four terms. So what you are going to do first in step one is you are going to factor out the GCF if there is one. If there is not, you can just immediately group up the two terms at a time. So I have a GCF here of 1 for this whole thing. There's nothing in common. So I'm just going to group the x cubed and the minus 2x squared together, and then I'm going to group the minus 9x plus the 18 together. All right, step number 2. This is where I'm going to be taking pair at a time, and I'm going to factor out the GCFs separately from each group. So the first group I have an x cubed and an x squared. So I think about my lowest exponent of x. So I'm going to take out an x squared. So I got x squared times x cubed over x squared, which is just x. And then I also took out an x squared to get a minus 2. And then I'm going to take out a minus 9. And I should have a x when I pull that out. And then actually a minus 9 times a minus 2. So there's a little typo there, so it's going to be a minus 2. Gets us to 18. And then step 3 is factor out the GCF from the entire expressions. So I got the x minus 2, x minus 2. That's my x minus 2 factor. And then, like I did before, I pair up the singles together. So I have an x squared minus 9. Now, there's a lot of 3s and 3.5s on this skill because some people assume that we're done over here, but that's actually not true. This is actually difference of two squares. So we should be able to recognize that square root of x squared is just x, square root of 9 is 3. So I'm just going to write this as x plus 3 times x minus 3. And you can kind of see how I set this up as a difference of two squares. So I got x squared minus 3 squared. So my final answer is x minus 2 times x plus 3 times x minus 3. And if we notice here, I have 3 factors. Now, I should have 3 factors because x cubed tells me that it's third degree. And the degree should match the number of factors. Example 8 is a lot like example 7, except this time we do have an initial GCF that we're going to take out. I always advise taking out that GCF immediately if there's one for all 4 terms. So I pull out a 4, and I have 3m cubed minus 6m squared minus 2m plus 4. And I'm going to group the two terms at a time. So I can take out a 3m squared on those first 2 terms, and then I can take out a minus 2 on those second 2 terms. And I do that, and I get 3m squared times m minus 2, and then I have a minus 2 times m minus 2. And then I want to make sure that I am putting the singletons together. So I got the 3m squared and the minus 2 together, and then the m minus 2 and the 4. And then I'm going to ask myself, can I factor 3m squared minus 2? Now, we can't write 2 as a perfect square. 2 is not a perfect square. So we can't use difference of two squares. So if we can't use difference of two squares, and if you tried the ACB chart with this, it wouldn't work. It's not factorable. So this is the completely factored form. So on your homework assignment, I really want you to be thinking about, can you factor the result anymore? And sometimes knowing when to stop is the challenge. So you can always try that ACB chart and see, if you can get something that works. But if there's nothing that works, that's going to be your final answer, cut and dry final answer. Example 9 is kind of illustrative about what happens if you forget the GCF. So if you forget to pull out the GCF, you'll get a 14x plus 16 and an x squared minus 1. So your grouping still is able to work, but you do have to pull out that 2 at the end. So I would just suggest investing up front immediately, pull out any GCF that you can at the beginning. So you can make sure that that 2 is all pulled out, so you don't have to worry about, the end result. But you do still have a difference of 2 squares for this one. On these more challenging examples, I do put multiple variables on. So for this one, I group a 3x squared and the minus 6xy together. So I'm going to pull out a 3x because 3 goes into 3 and 6, and then I got an x in both of the terms. So then I'm left with x minus 2y. And then over here, I'm going to pull out, well, 5 and 10 have a 5 in common. I'm just going to pull out a positive 5. So I got x minus 2y in the parentheses. So I got x minus 2y times 3x plus 5. If we really want to get interesting on this example, if you kind of think about when we group these two terms together, what does 30 and 24 have in common? Well, they have 6. Then take your lowest power of m, which is m cubed. That's what I'm going to pull out. And then this term has an n in it, but this one doesn't. So you can't really do anything with pulling out an n, this one. So then I got 6 times 5 is 30. M cubed times m squared is 5m squared. And then I got, I'm going to pull out a 6 from the 24. So I got 4 m cubed, already been taken out, but I just have an n. And then on this second group, I'm just going to pull out a minus 35 m squared n squared minus a 28 n cubed. So I'm going to pull out an n squared, again, minus 7n squared pulled out times 5m squared plus 4n. And I get that because minus 7 times 5 is minus 35. I already got an n squared out there. I need the m squared, so m squared goes in the parentheses. And then I pull out a 7. 7 times 4 is 28. N squared times n is negative 28n cubed. And then I'm just going to do a pair of the singles together. So I got 5m squared plus 4n times 6m squared minus 7n squared. So you can kind of see here this factoring by grouping, we've already done. And, it may have seemed a little bit difficult at first when we learned how to factor. But this way is very compatible with this factor by grouping idea. So you're really understanding, factoring from a GCF and conceptual standpoint. So we're just going to continue, getting a lot of practice with GCFs, pulling those GCFs out. Grouping 2 terms at a time. What's the GCF of the first 2? What's the GCF of the second 2? And then pair the GCFs together into their own factors. So this is kind of a very prevailing theme, in our Algebra 2 course.